Guys, so today we are going to have a look at polynomial equality. We've done a little bit of work on this. You wouldn't have heard the term before probably, but you should be able to recognize some of the techniques we're going to use. So let's have a look at a definition. Two polynomials are equal if and only if they have the same degree, so same order or same power. So you've got a quadratic and a quadratic, or a quartic and a quartic, and the corresponding terms have equal coefficients. Okay. So if you have x squared plus 2, that can never equal x squared plus 3, okay? So that's basically, and that should be pretty obvious, but that's polynomial equality. Okay, so let's have a look at an example of how to do this. So find constants a and b if z to the power of 4 plus 9 equals these two quadratics multiplied together. So the first thing we're going to do is expand them. And we remember when we're expanding something like this, we have to make sure every component from one side multiplies every component from the other side. Okay, so we're going to multiply that z squared into all of these terms, and then the same with our next one, the z, and then the same with our number 3. Okay, that's probably the easiest way to do these things. So the first thing we're going to do is say this is equal to z squared times z squared is z to the power of 4. Then I've got z squared plus times positive bz, which is plus bz cubed, and then z squared times 3 is plus 3z squared. All right, next in line is our a and z. We're going to use a bit of a technique here to make this a little bit easier. We're doing az times z squared, which is just going to be positive a z cubed. And you can see I'm grouping my powers of z. So we've got the cubes together here, and that's just so it's a little bit easier later on. So the next one is az times bz, which is plus a b z squared. Okay, again grouped with the z squareds, and then az times 3 is plus 3az. All right, last but not least, we've got to do 3 times z squared. We're going to get positive 3z squared plus 3 times bz, 3bz, plus 3 times 3 is 9. All right, now because we've grouped them in terms of the powers of z, we can just add them vertically. So if I do this, we've got a total of 1 z to the power of 4. We've got a plus b, lots of z cubed, plus we've got ab plus 6, lots of z squared, plus we've got 3a plus 3b, lots of z, and finally we've got plus 9. All right, so you can see by grouping them as we did, it made it a lot easier to keep those like terms together when we had to add them. Okay, so now what we've got to do is equate coefficients. So we're going to be equating coefficients. Because when we started, we knew we had z to the power of 4 plus 9, and that thing is supposed to be equal to this side. So what we can do is we can see that z to the power of 4, so I'm going to write it down here, so z to the power of 4 plus 9. So z to the power of 4, that's equal, so we can leave that alone. All right. When we have a look at our z to the power of 3, on our left-hand side, we don't have that. That means on the left-hand side equals 0, so 0. And on the right-hand side, it was a plus b. Now, we'll leave it there for now. So again, we'll equate our z squareds. So on our left-hand side, we've got 0 again. So 0, and that equals ab plus 6. And then our z's, we have 0 on our left-hand side. So that's going to equal 3a plus 3b. and then we've got a 9 and we've got a 9. So those match up. So the first term and the last term are correct, and the rest of them we're just going to have to equate. All right, so I've just moved up a little bit to give us some room. And what I'm going to do is just label this first equation as 1, the second one as 2, and the third one as 3. Now, for equation 1, we've got a plus b equals 0. That's the same as 0 equals a plus b. So if I rearrange this, I will get a equals negative b. Now, similarly, with equation 3, I've got 3a plus 3b equals 0. If I divide both by 3, I get a plus b equals 0, and therefore a equals negative b. All right, so that gives us the same information, which isn't really useful because if we've got two unknowns, we need to have two equations to work them out. But equation number 2 is a little bit different. So if I've got ab plus 6 equals 0, it means a b equals negative 6. Okay, and that's going to be really useful for us in our next little part when we combine these two things together. All right, so we know that a equals negative b and ab equals negative 6. So therefore, in number 2, we can put in a equals negative b. All right, so where we've got a, we can just put in negative b. So negative b times b equals negative 6. So what I'll get is negative b squared equals negative 6. Therefore, b squared equals positive 6 if I multiply both sides by negative 1, and b equals square root of plus or minus 6. Okay, and that's good. We worked out b, and now we can work out a. So again, I'm just going to keep writing down everything that I'm doing. So we're going to go back up here. So if I now go, therefore, into 1, what we just worked out, I know that a equals negative b. So our a equals negative of the b we just worked out, so plus or minus square root of 6. Now you may or may not have seen this before, so negative of plus or minus. So if I do a negative of a plus, I get a negative. If I do a negative of a negative, I get a positive. So instead of plus or minus, it's going to be minus or plus. So therefore, a equals minus or plus root 6, and b equals plus or minus root 6. So what that actually means is if a equals negative root 6, b equals positive root 6, or the other way around, if a equals root 6, b equals negative root 6. Okay, and you can put that into the equation and expand it as well if you want, and that should come out to be the same. So that's how we do this type. So another good type of question that we could be asked or we could be working on in this set is the following. So we're given a factor of a polynomial, and we're asked to find the other factors. Okay, so what we know is they've given us the polynomial, so x cubed plus ax squared plus 7x, minus 7x plus 6, my pen works, plus 6 equals, they've given us one factor, x plus 3. All right, and if we have a linear term, we know to get to a cubic, we need to multiply it by a quadratic. So what we do know is if we're doing a quadratic, the first term has to be x squared. Now our final term is just a factor of 1 in front of that. So we know it doesn't have to be a number. So if that had 2x cubed, we know this would have to be a 2 in front of it, but it's just 1. So we can just multiply the x and the x squared, so that will match. Fine. Now these middle terms, we're not sure what's going to happen. We can't obviously see the answer, so I'm just going to call that plus bx. And that can be any number, and we'll try and work that out later. And finally, we've got a 6 here on our left-hand side as our constant. And over here, we've got a 3. So you can only get constants when you multiply two constants. As soon as you get an x in there, it will not be a constant ever again. So we know that 3 times by 2 is 6. So we know that this last term has to be 2. Because it's the only way we can make a constant, and we know our constant has to be 6. Okay. So from here we can expand and we can equate some terms. So we are going to expand this right-hand side. And I gave you a little bit of a trick last time on how to expand easily. I'm not going to do that here, just to show you that you can do it the other way as well. All right, so we just have to multiply everything in by everything. So this x has got to multiply all 3, and so is the 3. So the first term is going to be x multiplied by x squared is x cubed. X multiplied by bx is plus bx squared. And x multiplied by 2 is 2x. All right, now I've got to do the same with the 3. So 3 times x squared is 3x squared. Then I'm going to get 3 times by bx is 3bx. And 3 times by 2 is 6. All right. Now you can see that we've got on the right-hand side, we've got a 6 here, which is what we wanted because that's what we've got on the left-hand side. And we've also got that x cubed. But let's go a little bit further. And let's equate all of our like terms. So we've got x cubed, and that's the only cube we've got. Plus, in front of the squares, we've got a b plus a 3. So b plus 3x squared. And we can do the same for our x's. So in front of our first x, we've got a 2. And we have also got a 3b in front of our other x. Plus 6. All right, so now we have to equate both sides, just as we did before. And I'm just writing it in so it's a little bit easy for us to see. So our x cubed is x cubed, that's fine. Now our ax squared is going to equal, so ax squared is, sorry, ignore me. We only care about the thing in front of the x squared, so that was a good mistake for me to make. So a equals b plus 3. So I'm going to call that equation number 1. And equation number 2 is going to be our negative 7 equals 2 plus 3b, because they are both in front of our x to the power of 1. Okay, so I'm going to call that equation 2. Now you can see equation 2 only has one unknown in it. So what we can do is we can just equate that. So if I take 2 from both sides, the 2 is going to disappear here. So I get negative 7 take 2 is negative 9 equals 3b. Divide both sides by 3, I get b equals negative 3. Okay, so now I'm going to put, I'll call this number 3. So 3 into 1. And again, I'm just writing everything I do, so everyone, it's very obvious where we're going with this. So if b equals negative 3, I'm going to get a equals negative 3 plus 3, which is going to equal negative 3 plus 3 is 0. So therefore, a equals 0 and b equals negative 3. So I could write my original equation as x cubed plus 0x squared, so that just goes away, minus 7x plus 6. All right, so that's what we're left with. But we've also been asked to find the other factors. Okay, so if I've got, hopefully I've got enough room here. If not, that's okay. So other factors, we know x plus 3 is a factor. And we can also substitute in x squared minus, we know b is minus 3, minus 3x plus 2. Now, again, we've got our simple version of factorizing. We're all very good at it, but just a reminder, as we've got to work out the number that multiplies to make positive 2 and adds to make negative 2. So we've got two numbers that multiply to make 2, it's 2 times 1, or negative 2 times negative 1. You can see if we add 2 and 1 together, we're not going to get negative 3, but we will on this case, which means our other factors are going to be x. We're going to get x plus 3, x minus 2, and x minus 1. And just to answer the question very specifically, we're going to say the other factors are x minus 2 and x minus 1. All right, and that's how we equate polynomials, and that's just a couple of examples. Thank you.